Okay, I will be going over your parent functions and your transformations. And this page here at the bottom, this is usually where students have the most trouble, and that's going to be talking about the dilations of the parent functions and whether or not you have a compression or a stretch. And that depends on where your A value is, whether it's located on the outside of the function or on the inside. In each one of these examples, we're going to discuss the type of transformation that we are given. So for the first one, we do need to identify the parent function. So the parent function would be f of x equals x cubed, or you can write out cubic if you wanted to. Both of those would be correct. And then the next part, you would have a transformation, and your transformation would be down 4. And we can get that from our reference sheet at the back of your notes. Right, so for our second function, the parent function here is going to be the square root function. And then we're going to have a transformation. Well, let's see, we're on the inside part of the function, so that means we are going to move left. Nope, it's going to go the opposite of what we think, so it's going to go right 1. And then we are going to have a reflection, and that reflection, we are going to reflect over the y-axis, and we know that because the negative's on the inside. So reflect is about the y-axis. And then we need to talk about whether or not we have a vertical or horizontal stretch or compression. Since 2 is on the outside, that means that we're going to have a dilation, and it's going to be vertical because the number is on the outside. And since it is on the outside and it is greater than 1, 2 is greater than 1, then we will have a stretch, vertical stretch by, and it's the exact number that you see, which is going to be 2. Okay, so looking at our next example, 3, our parent function here again is going to be x squared. So we're going to have f of x equals x squared. And for our transformations, it looks like we're going to go up 6 because of this plus 6 out here. And the negative sitting on the outside, that looks like we're going to reflect across the x-axis. So we're going to have a reflection. Reflect, and we're going to say the x-axis. And then, since we have a 4 on the or 1/4 on the inside, we do have a dilation. And with that dilation, notice it being on the inside, it looks like that we are going to have a horizontal, and that's going to be a stretch because on the inside it's opposite of what we would think. So we have a horizontal stretch, and it's going to be the reciprocal of that number. So it's a horizontal stretch by 4. And again, you can find all of the information for that under your dilations part of your reference guide. All right, so again, your parent function here is going to be your absolute value function, so absolute value of x. And we do have some translations here. The first one we are going to talk about is we're going to move down 2. Now that we're on the inside here, we are actually going to move left because it is the opposite of what you think on the inside. So we're going to go left 5. We don't have any reflections, but we do have a dilation. And notice the numbers on the inside. So that's going to be a horizontal. And since it's bigger, you don't have a fraction here, it's bigger than 1, it's going to be a horizontal compression. And it's going to be by the reciprocal of the number we see, so by 1/3. Okay, we have more of the same here, just some more practice. So our parent function again is going to be x squared. And then we have our translations. And so for one part, again, we're on the inside, so we're going to move the opposite of what we would think. So that's going to be right 6. And then notice we have this 1/2 sitting on the outside. So we have a dilation. And so we have to describe what kind. And since it's a dilation and you're sitting on the outside, notice it is on the outside, so this is going to be a vertical. And since it's on the outside, that 1/2, that's less than 1, so it is going to be a vertical compression. And it's going to be a compression by the value that's there, so compression by 1/2. Okay, number 6, again, more of the same. So here our parent function this time, though, is going to be that reciprocal function, or 1/x. And for our transformations, let's see, we've got a positive 3 sitting on the outside, so that means we are going to move up 3. I also have a negative sitting out here, and it's on the outside of it. So that looks like we're going to have a reflection. So we are going to do our reflection, or we're going to reflect across the x-axis. And this one is strange. You do have a compression, but this is going to be considered on the outside of the function. And here's why. This can be rewritten to be a negative 1/4 times 1/x plus 3. And so that's going to end up telling you that you really have a vertical type of dilation here. And we're going to have a vertical. And since this is on the outside and we have a fraction, this is going to be a compression. And it's by the value that we see, since it's on the outside of the function. All right, so moving on to number 7. So again, our parent function that we see here is going to be our cube root function. And our transformations here, we're going to move up 2. We are going to move left 1. And notice out here where you're going to reflect across the x-axis. And we're also going to have a vertical stretch. And that vertical stretch is going to be by what we see, which is 4. Okay, number 8, more of the same. And with this one, it might be useful to rewrite it to help us see that 1/2 is really going to be a horizontal stretch. So we're really going to say 1/2 times x minus 5. That tends to make things a little bit clearer on all of those transformations. So here we're going to have a parent function of the greatest integer function. So we have our greatest integer function. Now let's talk about some transformations. We see that we are going to move down 1. It looks like we are also going to move to the right because we're on the inside. We go the opposite of what we would think, so right 5. And we are also on the inside of our function. We have that 1/2. So it looks like we're probably going to have a horizontal since we're on the inside. And inside is always opposite of what we think, so it's going to be a horizontal stretch. And we're going to stretch by that reciprocal. So the reciprocal of 1/2 is 2. Okay, I know the excitement is building. We have yet more problems. Okay, so here again, our parent function is the absolute value function. And our transformations here, we're going to move up 7 from here. On the inside here, we're going to move right 4. And let's see, what else do we have? We have this negative here, and notice it's on the inside, so that means we are going to reflect across the y-axis. Again, it's because it's on the inside. Reflect across the y-axis. And what else is this going to do? We're on the inside, so we have a horizontal, and that's going to be a stretch, even though it's a fraction, but it's because we're on the inside. TCH, my goodness, I'm having a Mr. Fox moment. It's TRETCH. All right, horizontal stretch by the reciprocal, which is 3. And finally, number 10, describing these transformations once more. Of course, our parent function here is going to be x cubed. Transformations, we are going to move down 8. We are going to move left 3. And we've got to address all of this on the outside. So we have a negative on the outside portion, so we are going to reflect across the x-axis since it's on the outside. And then we also have a fraction here, but notice that fraction, 3/2, is really the same thing as 1 1/2, so that's bigger than 1. So they were trying to trick us here. This is going to be a vertical, and since it's on the outside, that's why it's vertical. And it's also going to be a stretch because we have a value larger than 1. So it's a vertical stretch by, and we see it's 3/2. Okay, now we're looking at our graph and trying to write in some different transformations based on what it's telling us. So for the first part, they want us to identify what parent function we're looking at, and that function is going to be the absolute value of x. Now, if we want to translate 2 units right, then we need to write the function that it would look, or how it would look in function notation. 2 units to the right, that's going to be on the inside, and it's going to be the opposite of what we think. And then we're going to talk about reflecting in the x-axis and translate 5 units up. So if we want to reflect in the x-axis, that negative's got to go on the outside. And then moving 5 units up, we would add a plus 5 on the outside. Okay, so for our next one, number 12, our parent function is that reciprocal function. So we're going to have f of x equals 1 over x, and then we are going to translate 7 units down and 3 units right. So 7 units down means I'm subtracting 7 on the outside. However, 3 units left, that's going to be really x plus 3 on the inside of the function minus 7. And finally, we need to do a horizontal stretch by a factor of 3. Now remember, horizontal meant the number had to be on the inside, and that stretch was caused by a fraction, and we have a factor of 3, so that means that we're really got to be careful with this. So our function here, let's just address that first. We're going to have 1 over, because again we're dealing with that reciprocal function, and so we're going to have 3 is going to be down here, and let's see, a vertical stretch by a factor of 3. So, and then we're going to translate 2 units right. So I know I've got to subtract 2 also inside that function, so I need parentheses. So there's what that one's going to look like. And again, remember that by a factor of 3, that's really the reciprocal of the value. And I know that because of the horizontally stretched. Okay, number 13, the parent function here is going to be that greatest integer function. So we're going to have f of x equals our greatest integer function, which looks really strange in notation, but there it is. And then we need to talk about a vertical stretch by a factor of 4, so vertical means outside, and translate up 1 unit. So our function then from here is going to be 4 times the greatest integer function. That 4 is going to sit on the outside because of vertical, and translates up 1 unit. We're going to do plus 1. Okay, for our next one, a vertically compressed by a factor of 1/3. So that's going to look just like it's supposed to. You're going to have that 1/3 on the outside, and then you are going to translate 2 units right. Or, oh, no, 2 units left. So here, what we're going to do, we have f of x equals vertical compression by a factor of 1/3. So we're going to have 1/3 times our greatest integer function. And we're also moving to the left 2 units, so we're going to say plus 2 here. All right, so moving on. The next one, our parent function is going to be our cube root function. So we are going to have f of x equals the cube root of x. The next, we need a reflection in the y-axis and translate 4 units right. So if we're reflecting over the y-axis, that means our negative's on the inside of our function. And we're also moving to the right 4 units, so that's going to be a minus 4. All right, and let's see, what else do we have? No, we need parentheses there. Yeah, that's going to make sure all of that happens. Sorry, folks. That looked strange for a moment. All right, part C, horizontally compressed by a factor of 2. So horizontal means inside, and factor of 1/2, that means I need to flip that to be 2. And translate 5 units down. So we're going to have f of x equals, and remember horizontally means inside, and it's the reciprocal. So we're going to have 2x, and then we're going to move 5 units down, so it's going to be a minus 5 on the outside. All right, so for our next examples, we have a few things we have to consider with this. They've given us a function here, but then they're going to move this function. So it might be easier for this to do just a little bit each step. The first part of this, they want us to reflect across the y-axis. So if we're reflecting across the y-axis, then we know we have to have a negative on the inside. So that's one thing to consider. Then we are translated 6 units to the right and down 2 units. So let's see if we can write this function out. So f of x equals, now we're not changing this vertical stretch any, so I'm going to leave that 2 out there, times, and we're going to reflect this about the y-axis, so that negative needs to be on the inside of all this. And then we have our x. Now we're already to the left 5, and I'm going to go, to the right 5, and I'm going to go right 6 more units. So really I need to move 11 to the right. So hopefully that makes sense why that's 11. And now notice where my squared is. It's on the outside, but it's also making sure that this negative here is included in that. Be careful, because we need the negative on the inside because we're reflecting across the y-axis. Now we need to also take this function and move down 2 units. Well, that means here I'm already up 3, but if I move down 2, then hopefully I've only moved up 1. And that's going to be what our new function looks like. Okay, so again, let's see, number 16, very similar. However, they're giving us what has happened after the translations have occurred, and they want to know what was the original function. So they've taken, this is really the answer. Notice up here with 15, this was the new function. Now they're giving us the new function and wants to know, well, what was the original function? So we're going in the other direction. So we have to be careful for sure. So what this is going to say is that we had, let's see, an original function, and we stretched it by a factor of 2. Well, if I stretched it by a factor of 2 and got 6, then I had multiplied. And what did I multiply to 2 to get 6? Well, that's going to be a 3. So there's where that part is. Then we translated 2 units left. Well, if I moved 2 units left and I ended up with a 4, well, let's see, that's going to be 4 minus 2, really. So we're going to end up with x plus 2. And again, you can double check this by thinking of, okay, this is my original. Well, if I move it 2 more units left, that would be a plus 4 on the inside. And then we moved 5 units up. Well, I have a negative 1 here. And so that's where I ended up after I moved 5 units up. So where was I originally? Well, I was originally at negative 6. So that one we're having to go in the opposite direction. Just be careful on those.